Welcome to the spoken tutorial on control flow and event handling. In this tutorial, we are going to learn how to use if-else statement, how to handle time and state events, how to use when statement. To record this tutorial, I am using Open Modelica 1.9.2 and Ubuntu operating system version 14.04. But this process is identical in Windows, Mac OS X or Fossey OS on ARM. To understand and practice this tutorial, you need to know the following: equation-based modeling of physical systems, branching in any programming language, class definition in Modelica. Prerequisite tutorials are mentioned on Spoken Tutorial website. Please go through them. Freefall class was already discussed in previous tutorials. Now let us add a constraint to it. Ball is at rest until t equals 0.5 seconds. Freefall under gravity starts at time t equals 0.5 seconds. I have created a model named time event example which simulates this condition. Time event example file is available in code files link on Spoken Tutorial website. Please download and save all the files in code files link. For your convenience, Freefall class is also made available. Now let me go to OM Edit. I have already launched it on my system. To open OM Edit on Ubuntu operating system, click on Dash Home icon at the top left. Type OM Edit in the search bar and click on OM Edit icon. Let me go back. Windows users may similarly search for OM Edit in Start menu and open it. To open time event example file, click on the tool named Open Model or Library file. Locate time event example file in your system and click on Open. You may alternatively use the File menu to open this file. Note that time event example has appeared in Libraries browser. Right-click on this icon and select View Class. The model has now opened in diagram view. Click on third button, which is the text view. We have already discussed that model and class are used synonymously in Modelica. The name of this model is time event example. Comments such as this may be written on the first line of a model or class. H, V and G represent the same quantities as in Freefall class. Initial equation section contains initial conditions. Value of H at time t equals 0 is 30 meter. Value of V at time t equals 0 is 0. Equation signifies the beginning of equation section of this model. Now let us see how to insert the constraint explained in slides. Note that there is an if-else block in equation section as shown. Let us try to understand each statement of this if-else block. If statement places a constraint on time variable. Time is a built-in variable in Modelica. It needs not be explicitly declared in a class or model. The ball experiences free fall after time 0.5 seconds. Hence, these two equations represent the same equations as those in freefall class. Else branch contains equations which are executed when time is less than 0.5 seconds. The ball is at rest when time is less than 0.5 seconds. Hence, these two equations hold good in that case. End if signifies the end of if-else block. The model is now complete. Let us simulate it by clicking on Simulate button. Plotting perspective has now opened. Select H in the variables browser. This generates H versus time plot. Since the ball is at rest until time t equals 0.5 seconds, height remains the same. To delete the result, right-click on time event example in variables browser and select delete result. To go back to modeling perspective, click on modeling button at bottom right. Now let me delete the second equation in else branch. Click on save button in the toolbar to save this model. Click on simulate. The simulation has failed. Go to the messages browser and scroll up to see the error message. The error message says that the number of equations in each branch should be the same. Therefore, the number of equations in if and else branches should each be equal to the number of variables. Let me insert the equation back in its place and click on save button. Note that DER of h equals v is an equation which is common to both if and else branches. Hence, the if-else block can be replaced by two statements. Let me show you how it is done. Delete the if-else block first. The equations to be typed here have been provided in a file named if-else-statement.txt. This file is also available in code files link. Since it is a text file, I have used gedit to open it. Let me go to gedit. Windows users may open this file using Notepad or any other text editor. Copy the two equations. Go back to OM edit. Do a right click and select paste. Click on save button in the toolbar once again. Click on simulate. Close the pop-up window. Select h in the variables browser once again. Note that the h versus time plot is the same as in previous case, which indicates that both models are the same. To delete the result, right-click on time event example and select delete result. Click on modeling button at bottom right. This is an if-else statement which indicates that if time is greater than or equal to 0.5, dv by dt equals g, otherwise dv by dt equals 0. Now let me go back to the slides. Please note that the number of equations in if branch should be equal to the number of equations in else branch, and both of them should be equal to the number of variables in the class or model. Event is an abrupt change in behavior of a system. Events may be categorized into time events and state events. In a time event, the time at which event occurs is precisely known. Time event example handles a time event at t equals 0.5 seconds. State event occurs when a system variable crosses certain value. Let us try to understand state events using an example. A ball under free fall faces a state event on touching the ground. The following behavior is observed when it hits the ground. Velocity of ball reverts in direction. Magnitude of velocity changes if the collision is inelastic. I have created a model named bouncing ball to simulate this behavior. This file is available on Spoken Tutorial website. To view this model and simulate it, let me go back to OM edit. Click on Open Model or Library File tool. Locate bouncing ball file in your system and click on Open. Right click on bouncing ball icon in Libraries browser and select View Class. If the model does not open in text view, go to the top of modeling area and click on text view button. E is coefficient of restitution for inelastic collision of ball with earth. It is a parameter and its value remains constant at 0.8 throughout the simulation run. Radius represents the radius of ball in meter. H, V and G represent the same quantities as in time event example. These two equations of motion have already been discussed in free fall class. When statement is used to signal an event, it is used to specify the action to be taken when an event occurs. H less than or equal to radius holds true when the ball is in contact with ground. This statement is executed whenever the event occurs. Reinit function is used to reinitialize a variable. Here it reinitializes velocity of ball with the negative product of E and velocity of ball before touching the ground. To simulate this model, click on Simulation Setup button in the toolbar. Under General tab, change Stop Time field to 30 units and click on Simulate. Close the pop-up window. Select H in Variables browser. Note that H drops below 0, which is unacceptable. We have seen similar behavior while simulating freefall class. This faulty behavior is due to numerical errors. A discussion of numerical errors is beyond the scope of this tutorial. Please refer to Zeno behavior of bouncing ball for a better understanding. Let me deselect H. Let us go back to the slides. When statement is used to signal an event, reinit of a, b assigns value of b to variable a and resumes simulation. Pre of a returns the value of variable a before event. For example, reinit of a, 10 assigns a value of 10 to a when event occurs. The faulty behavior of bouncing ball model is corrected in Bouncing Ball with Hysteresis. Bouncing Ball with Hysteresis model is available on Spoken Tutorial website. Simulate bouncing ball with hysteresis and generate H versus time plot. Notice the difference between bouncing ball and bouncing ball with hysteresis. This brings us to the end of this tutorial. Watch the video available at following link. It summarizes the Spoken Tutorial project. We conduct workshops using Spoken Tutorials, give certificates. Please contact us. If you have any questions related to this Spoken Tutorial, please visit the following website. Under Textbook Companion Project, we coordinate coding of solved examples of popular books. We give honorarium and certificates to those who do this. For more details, please visit the following website. Under Lab Migration Project, we help migrate commercial simulator labs to Open Modelica. For more information, please visit the website. Spoken Tutorial project is supported by NMEICT, MHRD, Government of India. We thank the development team of Open Modelica for their support. Thank you for joining me in this tutorial. Goodbye.